All right, today we're going to talk about conditional statements. Conditional statements and some definitions. What's going on, participants? All right, inductive reasoning. It uses a number of specific examples to arrive at a conclusion. Inductive reasoning is when you use a number of specific examples to arrive at a conclusion. Conjecture. That's the conclusion you make using inductive reasoning. Inductive reasoning, you use a number of specific examples to arrive at a conclusion, and then you make a conjecture or a conjecture. That's the conclusion you make using those specific examples. Okay? So in some of your practice today, you'll be asked to use inductive reasoning to make a conjecture. So that's what it means. Use specific examples to make a conclusion. All right? It's just a geometry / fancy way of telling you to use specific examples to arrive at a conclusion. The conclusion is your conjecture. All right, so sometimes it's like when you're looking at a number pattern, right? If you're looking at a number pattern, you're looking at specific examples. I mean, as simple as it gets, if you got 2 and you got 4 and you got 6, and you're asked to pick the next 3 terms in the sequence, right? Well, the next 3 terms in the sequence, it looks like they're going to be 8, 10, and 12. If you're asked to use inductive reasoning to make a conjecture, well, you're going to use your specific examples that you use are the first 3 terms that are already given. All right? The conclusion you're going to make is what the next 3 terms are going to be. So you look at the first 3, you say to yourself, well, they are the first 3 even numbers. All right, so I'm going to continue this sequence of even numbers. That's using inductive reasoning to make a conjecture. Counter example. Whoa. A counterexample is a false example can be a number, a drawing, or a statement. Or it can be an event. So if you were asked to find a counterexample for the statement, if n is a real number, then n squared is greater than n. Find a counterexample. That's a false example. So find a false example for the statement. If n is a real number, then n squared then n squared is greater than n. The counterexample would be when n is 1. Because 1 squared is not greater than 1, is it? 1 squared is not greater than 1. 1 squared is equal to 1. So for this statement right here, if n is a real number, then n squared is greater than n. If you're asked to find or list a false example, a counterexample, well then when the value of n is equal to 1, that's a false example. All right? A counterexample is something showing that a statement is untrue. All right? And then giving an example of the statement being untrue. You guys okay with those terms? Very good. Very good. The truth value of a statement is to determine whether a statement is true or false. Kind of like your homework, your electronic homework. All right? You're determining truth values of statements. If you're asked to find the truth value of a statement or determine the truth value of the statement, all you're doing is determining whether the statement is true or false. And a lot of times you'll be asked, determine the truth value of a statement. If false, list a counterexample. Okay? So if the statement is false and you say that it's false, you have to list an example showing it to be false. Make sense? So if we go back to this, statement, if n is a real number, then n squared is greater than n. What's the truth value of that statement? Very good, it's false. And if you're asked to list a counterexample, your counterexample will just be this right here. Please turn green. There's your counterexample. All right? This is your truth value. The counterexample is just an example to support a false truth value. Everybody okay with that? All right. The negation of a statement. Has the opposite meaning. As well as opposite truth value. All right, which is going to take us into conditional statements. So all of this is going to kind of sort of start tying together here in a couple minutes. So a conditional statement is written in if-then form. If-then form. Example would be if you would like to speak to a human, then press 1. That's a conditional statement. It's in if-then form. If something, then something else. In this case, if you would like to speak to a human, then press 1. A conditional statement has a hypothesis The hypothesis is what follows the if, and a conclusion. And that is what follows the then. Conditional statement has a hypothesis and a conclusion. Hypothesis. I need a fatter marker. Yeah, let's go here. Hypothesis is what follows the if. So back to this conditional statement right here. The hypothesis of this statement right here. Speak to a human. Like to speak to a human. Would like to speak to a human. That's all the hypothesis. It's everything after the if. Doesn't include the if though. The conclusion to a conditional statement. The conclusion. It's what follows the then. The conclusion to this conditional would be press 1. The conclusion doesn't include the word then. The hypothesis doesn't include the word if. It's the actions that are happening after the word if. The conclusion is the action or event or number that's taking place after the word then. This hypothesis, let's see, how's the best way to write this symbol for a conditional statement? Symbol for a conditional. P arrow Q. And you read it, it's read, if P, then Q. Where P represents the hypothesis and Q the conclusion. So we got the conclusion follows the word then. It's represented by the letter Q, this lowercase cursive q, here and here. The hypothesis of the statement, the hypothesis of a conditional statement follows the word if. Hypothesis follows the if. It's represented by the lowercase cursive p. The symbol for a conditional, P arrow Q, is how you would refer to it, but you would say it if P then Q. So if you're asked to identify the hypothesis and conclusion, and you're given the statement, if a polygon has 6 sides, then it is a hexagon. And in order to save some time on writing, we'll just continue to use colors. The hypothesis of this statement is that a polygon has 6 sides. The conclusion to this statement is that it is a hexagon. It's that simple. It's that simple. Now, where it gets a little more difficult is when your conditional statement, all right, this is the conditional right here. Let's write another conditional. A number is divisible by 10 if its last digit is a 0. In this case, when you don't see the word if and then, you will see one of the words. And right here, if we're identifying the hypothesis and the conclusion, and the hypothesis follows the if, here's the if. And what follows the if is that the last digit is 0. There's your hypothesis. Last digit being 0. When they're talking about its last digit is 0, you can say a number's last digit is 0. You can just say the last digit is 0. There's your hypothesis. It's what followed the if. Now, the rest of the statement is what would follow the then if the word then was in there. But this statement doesn't have a word then. So by process of elimination, the conclusion to this statement is that the number is divisible by 10. So sometimes you got to use a little bit of a process and elimination, or the process of elimination, to determine the hypothesis and the conclusion. And there's an example. converse of a conditional. Let's say the converse of a conditional is written by switching, how do you spell switching? By switching the hypothesis and conclusion. Symbol. Q arrow P, which you would read if P, then Q. The conclusion of a conditional is written by switching the hypothesis and the conclusion. So we're going to go back to, I'm going to star this one right here. This statement that we started with. All right. The conditional statement was if a polygon has 6 sides, then it is a hexagon. If you had to write the converse of that statement, the converse of that statement would be if a polygon is a hexagon, then it has 6 sides. There's your converse. We switched the hypothesis and the conclusion. We took the original hypothesis and we put it after the then. And we took the original conclusion and we put it after the if. And we modified the wording just a little bit to make it read as a sentence should read. Okay? It's the second type of conditional statement. You've got a conditional, then you've got a converse. Then you have an inverse. The inverse of a conditional. Negates the original hypothesis and conclusion. Symbol. This little squiggly line, P, arrow, squiggly line, Q. Reads, if not P, then not Q. If we're going to write an inverse to the original conditional, back up here, this original conditional says, if a polygon has 6 sides, then it is a hexagon. The inverse to that statement is, we're going to negate the original hypothesis and conclusion. We're going to say, if a polygon does not have 6 sides. Then it is not a hexagon. The last conditional statement is called the contrapositive. Of a conditional. The contrapositive of a conditional negates the converse. The contrapositive of a conditional negates the converse. So the symbol we go back to the converse, which was Q arrow P, if Q then P, and we negate it. So if not Q, then not P is how it reads. That reads, if not Q, then not P. And then when we write that contrapositive, we're going back to the converse and we're going to negate it. So the converse said if a polygon is a hexagon, so we're going to say if a polygon is not a hexagon, then it does not have 6 sides. Okay, a lot of writing, not much math, but unfortunately or fortunately, it's just part of the class. Got to cover it. We have to cover conditional statements. You have to understand what a conditional is, what its converse is, what the inverse is, and what a contrapositive is. Now, here's a little chart that, well, ooh, don't do that. Here's a little chart that will help you remember/memorize this or these conditional statements. Okay? If we condense this down to the 4 conditional statements, and we're going to call this related conditionals. We got a converse, an inverse, I'm sorry, we have the conditional. The original conditional statement. And we have a converse to that statement. We have an inverse of that statement. And we have a contrapositive. Four related conditionals. There's the name of the statement. Here's the symbol. If P, then Q is your conditional statement. You write your converse by switching the original hypothesis and conclusion. So we call it if Q, then P. We write the inverse by negating the conditional. If not P, then not Q. And we write the contrapositive by negating the converse. If not Q, then not P. And that is a very simple way to narrow everything that we talked about down to that simple little chart. 4 statements: conditional, converse, inverse, contrapositive, and the symbol that represents each. If P, then Q. If Q, then P. Not P, not Q. Not Q, then not P. All right, it's a very simple way to memorize this information for your quiz on Friday. All right, good. Ready for some practice? Thought you would be. So let's see where we are in this workbook here. You did your 2-dimensional figures yesterday. All right, so here's some practice for today. You still writing? I'm sorry. Page 15. Write a conjecture, make a conjecture, determine whether the conjecture is true and false, give a counterexample. Okay, page 15, 1 through 12. All right, and then you're going to do page 19. What you're going to do is page 19, 1 through 5. But we're going to change the directions a little bit. The directions for page 19, 1 through 5. Are to write a conditional, converse, inverse, and contrapositive for each statement. And I'm going to say list by symbol each statement. And what I mean by that is when you're writing those statements, you're going to write 4 sentences for 5 problems here. So you're going to write 20 sentences. Write a conditional, converse, inverse, and contrapositive for each statement. List by symbol each statement. So you're going to say, if P, then Q, which is the conditional. And then you're going to write the conditional. You're going to list the symbol, if Q, then not P, then P, which is the converse. You're going to write the converse. Inverse, you're going to negate the original hypothesis, and then you're going to negate the original conclusion, and then you're going to write it out. And then you're going to write your contrapositive, where you're going to negate the conclusion, you're going to negate the hypothesis. Oops. And you're going to write the sentence. So over in the margin on the left-hand side of the paper, you're going to put the symbol for conditional, and then you're going to write it. And then in the margin, you're going to write the symbol for inverse, and you're going to write the inverse. Symbol for converse, symbol for inverse, and then write it. Symbol for contrapositive, and then write it. Yes? Yeah, when you want to go to the bathroom, all you got to do is bring me your planner. You don't have to ask. And I'll stamp it for you. All right, so here's your assignment for today. E-learners, you are excused if you don't have any questions. In-classers, get to work.